everybody. Dr. Daniel Barth here with the How Do You Know program, sponsored by Explore Scientific, and of course, by my favorite astronomy book and yours, Star Mentor. We wrote Star Mentor just for you if you are both an introductory astronomer or if you're an experienced astronomer wanting to help others get into the hobby. Star Mentor is a book of activities and exercises. When you have the question, and everybody does when they first get a telescope, what do I do next? I wish I had an astronomer here to help. Well, with Star Mentor, you've got an astronomer in your pocket that you can help guide you through activities and help you learn the sky, learn to use your scope, and learn to enjoy the hobby. Now, for today, we're doing episode number 80, which is, again, searching for dark matter, and we're looking at some more coming out on the front. But let's go ahead and talk about astronomy and space science news, the fun stuff that's in the news lately. Amateur astronomers just the last couple of weeks spotted a new impact on Jupiter, which is really exciting. If you are old enough to remember back into the 1990s and you remember Comet Shoemaker-Levy 9, and if you're a fan of Explore Live programs, you've probably seen Dr. Levy any number of times. And that was the first time in 1992 we had seen an asteroid or other body collide with a planet other than our own. And now we're talking from 1992 to 2023, so we're talking roughly 30 years. And in that 30-year span, we now have live video of a quality that's suitable enough that amateur astronomers now have a network of telescopes that are automated, and they keep track of the planet. How do you see an impact unless you're watching all the time? You have to be really, really lucky. But with new automated telescopes and with new video equipment and high capacity storage, we can actually take video of a planet and we can have it for hours and hours, and computers can go ahead and search that footage so we don't have to, looking for anomalous events. And indeed, the OASES is the organization. That's the Organized Auto Telescopes for Serendipitous Event Survey. Serendipitous, of course, would mean, ooh, I just got lucky. Look, it happened at the same time. I don't know if you're watching all the time with video, if it really qualifies as serendipitous, but OASES is a great name for an organization. The other interesting thing we had come up, and we've talked about this with axions. We have two news items about axions this week. And the first one is a possible detection of an axion particle. This came through the Xenon experiment, Xenon, folks. The Xenon experiment, which is being run by astronomers and physicists in Italy. And they have built this marvelous detector. And what they're looking for is not the axion, which is a weakly interacting particle, but they're looking for its decay products. Again, much of physics and particle physics and is like this. If you're looking for a product of a particle, oftentimes the particle is too hard to detect, too rare, or too short-lived. So you do your theoretical research and you say, oh, if we have this short-lived, hard-to-detect particle and it decays, what will that look like? You run your best physics and math according to the models, and then you set up a detector to look for these very rare events. And with the axion, they have set up this detector. And if you download today's show notes, there's a lovely photo of this detector. And this thing is about 1 meter wide. It's quite large. And this axion detector is supposed to detect the decay products of an axion. Now, I have to tell you, the axion is an hypothetical particle. We have some theories which seem to predict that an axion should exist, and yet should exist to have actually having the eureka moment, I found it, is a long journey. In this case, as in many cases with this sort of theoretical physics and astrophysics, the detection event is going to be at the very threshold of what we can measure. In other words, we're putting together detectors, and let's say between one generation of detector and the next, you get an order of magnitude improvement. The new detector is 10 times better. Oftentimes what we're working with is experiments where the theoretical detector